guess it's ready. Well, my name is Guillermo Esteban Mas Moreno, and I'm going to explain topics 6 and 7. Okay, to begin with these topics, we are going to talk about atoms. Okay, the main bases are the atoms. What are we going to talk about atoms? We're going to talk about the charge of the atoms. What does charge of the atoms? Well, firstly, we need to know that atoms can be charged positively or negatively. Okay, it depends. We have the electrons, which atoms are formed of three bases: the electrons, the neutrons, and the protons. Okay, the electrons are the ones who carry negative charges. The neutrons are the ones who carry neutral charges, and the protons are the ones who carry positive charges. Okay. Well, the structure of an atom, basically in the center we have the neutrons and protons. Okay. And we have like other layers that are around the center of the atom, and in those layers we have the electrons flowing around the atom. Okay, each atom has a different amount of electrons in these rings. Okay, in these outer rings, and it's called the valence electrons. Okay. These valence electrons determine if the material is a conductor or a non-conductor. I'm going to explain what a conductor is and what a non-conductor is. Okay, conductor basically is the name given to a material who has the capability, the ability maybe of letting electric charge to flow through it. Okay, the non-electric is the opposite, the material who does not have the ability or the thing that lets electric charge flow through that object. I'm going to read this because this is something that it's stated, it's a phrase. Coulomb's law stated that the interaction between charged objects is a non-contact force that acts over some distance of separation. Okay. The formula of this force of attraction or repulsion, it's the next one. It's going to appear in your screen. Okay. We have Q1 and Q2, which are the positive. Which are the charges of the electron. Q always represents the charge of the atom. Okay. In this case, we have two charges. Okay. This is for when we have two charges, because we are talking about two charges. Okay. Why are we talking about two charges? Because the charges of the atoms, okay, generate an electric field. Okay, this electric field, depending of the type of charge of the atom, is going to be attractive or repulsive to the other one. Okay, let's say if we have an atom with a positive electric field and an atom with a negative electric field, they're going to attract each other. Why? Because opposites attract. If we have a positive charge atom and a positive charge atom, they would actually repel. With this formula, we can calculate that force that is interacting between these two atoms. Okay, so that's why we are using these two atoms. We need the value of atom 1 and atom 2 in order to calculate the force that is interacting between these two charges. So basically that's all. That's all for topics 6 and 7. I'm going to let you with the experiment and the explanation that are going to show you a bit more how does this topic talks about.
example of the experiment. Well, for the experiment we will need a big gas battery and graphite. Now, we'll put the graphite here and nothing happens. Well, we will try with a bigger thick graphite. Nothing happens.
Sí estaba funcionando, pero de una manera muy extraña. Ya.
Vale.
Mira. Nada más tenemos que esperar. Se ve aquí muy poquito, pero se ve. Y con el tiempo se empieza a romper, a craquear, ¿sabes? Eso es lo épico. Llévalo, ¿sabes? No, digo.
Okay, in this experiment we can see an example of electric potential difference and electric potential energy. So, this is the data that we're going to use. The electric charges of the battery, positive and negative, and the distance. So, this is the formulas for electric potential energy and electric potential difference. Now, we're going to substitute the electric potential energy, and now we solve. Now we know that this is our electric potential energy. With this information, now we're going to substitute the electric potential difference formula. We solve, and now we know our electric potential difference.
I'll explain you what the Gauss law is about, but first we need to know some terms to understand the theory. The electric field lines that pass through a surface area are called electric flux. In this case, there is a particle moving in a specific direction over a specific location. The number of these lines, or electric flux, depend on the surface of the area, the strength, and the orientation of the surface. Now that we know what electric flux is, we'll get to Gauss' law. It established that the electric flux through any closed surface, known as Gaussian surface, is equal to the charge inside divided by the permit of space. Charges are the source and sinks of electric field. Something interesting about this type of law is that its calculations are not quite real. The Gaussian surface doesn't respond to a real object. Instead, it's a mathematical construct that could have any closed shape. Another highly important point of Gauss' law is that it develops in space. When a force is conservative, then the work depends only in the initial and final position. We know that the potential energy depends on the position of an object. Additionally, electric potential energy is the energy needed to move a charge against an electric field. If potential energy is either positive or negative, consider that every time a positive charge moves against the direction of an electric field, the potential energy increases, and every time that a negative charge moves against the direction of an electric field, the potential energy decreases. The potential difference is the difference between 2 points in an electric field. On the other hand, the electric potential difference is the electric potential energy per unit charge. It's the amount of work needed to charge from a reference point to a point against an electric field. Adding to this, equipotential lines are around a charge and when the charge interacts within an electric field and have the same electric potential. The last topic of this explanation are electron volts. You may have heard of this thing. It kind of sounds of a daily use measurement. Electron volts, specifically electron charges, are used to define an energy unit which is useful in calculations involving nuclear and atomic systems.
Hi, today in the experiment we're gonna see electrostatic, and for that we're gonna need this wire and these pieces of foil paper, which we're gonna put in here so that they will be hanging. So now what we're gonna need is to make friction with this tube of PVC and this cloth. So hopefully this is gonna make friction, and if it's correct, there's gonna be a charge that is gonna move.
Hello, darkness, my old friend. I've come to talk with you again, because a vision softly.
Well, in this experiment we can see an example of electric field magnitude. This is our data that we're going to use. The electric charge of the battery.
In this part, my classmate said battery because the electric field that generated the PVC tube couldn't be measured, so we used a value that could be like measured with simplicity. So we used the value given by battery, the battery that you saw in the first experiment. Just wanted to make clear that it's not an error or a mistake from us, from communication or something like that. The thing is like that we couldn't get the exact values to give you a clear example from this explanation of the experiment. So we used the values that could be exact, just for you to understand clearly this experiment.
And the distance from the battery to the object inside the electroscope. These are formula, so we're going to substitute the data in the formula and then we solve. This is electric field magnitude from the battery to the object inside the electroscope.